at industry scale. And today we have with some of the eminent people, both at government level and in industry and policy making people. So the panel members include Dr. Ravi Asthana, and he has been there in the DST for quite a long time, and then he is the head of the Mega Science projects. And also he was head of the country astronomy document. And we also have here Dr. Anand Deshpande, and I don't think you need much introduction to him. And he's the founder and the chairman of Persistent Systems, and he founded the company in 1990, and then now it is a multi-billion-dollar company. And then just looking at the market cap is around 35,000 crores. And it's not just a company, but he's a doctorate in doctorate in engineering and computer sciences from Indiana University, and also he deals with quite a number of things. And in fact, he has one what's called a non-government organization, and which deals with providing employment, self-employment to the people. And Anand also holds numerous positions in the country, particularly in the policy making for the business, like NASCOM Executive Council and ACM, which is called Association for Computer Missions, etc., etc. And also he's the founder member of IISc, that is India's first product think tank for creating entrepreneurial ecosystem in the country. Welcome, sir. And another is Mr. Laxmesh, who is one of the panel members. And he comes from L&T, and he's vice president and the head of missiles and aerospace business, Larsen and Toubro. And he's a mechanical engineer with the business masters. And of course, he made a lot of contributions within L&T for developing and implementing very unique strategies in business development and operations. And he also manages talent management within L&T and contributes to core sectors like hydrocarbon, nuclear, and defense aerospace. And he's instrumental in delivering many key projects to mostly public sector companies like DRDO, BRC, and ISRO, something like that. He's also a member of various national policy making bodies, something like IISc, that is called Indian Society and System Engineering, things like that, and also his national committees for space engineering. And finally, the other member is Professor Sinha. He's from Indian Institute of Sciences, and he was a professor there for more than 30 years, and teaching and doing the R&D, things like that. And he did his BSc from Patna University and the ME and PhD from Indian Institute of Sciences. And then after the superannuation, he started a company called Lab 2 Market. And so his expertise lies in quite a bit of technologies, power electronics, fault tolerances, and things like that. So they delivered a number of projects for Indian railways and things like that. So DRDO projects, and then of course he also the multinational companies also he got projects and then delivered them, like Motorola and Tejas, something like that. So we have quite a variety of the eminent personalities here, and they have vast experience in dealing with Indian developmental systems, and hopefully they provide a lot of insights into how to go about integrate both our academics and the industry. As I said earlier, because now it's not anymore at the institutional scale we are doing it, is much more industrial scale, and we really need to integrate these two the organizations well. So I request Pravir Asthana to say a few words before going into the other panels to say more into this. Dr. Pravir Asthana. You are muted, Dr. Pravir Asthana. That's going to be Ravi.
Can you hear me now?
We can hear you.
Yeah, because I had been locked. So anyway, okay. So thank you very much, Dr. Reddy, for a kind introduction. And I have just prepared 2 slides as per your timeline. So let me try to share that those slides. And okay. No. What happened? Can you see my slides?
Yes, we can see you.
Okay. So there are only 2 slides, and I thought I will try to mention the questions with which we struggle while discussing the participation of industry in mega science projects. So I thought I'll flag those questions, some of those questions, and then listen to the leaders from the industry, and at least it could be the first step forward in this direction. So as we all know, mega science projects are to start with massive engineering projects. Once they are constructed, they're huge instruments to do frontier science, but during construction, they are massive engineering projects. But the main difference between these projects and suppose an expressway or something like that is that the underlying technologies are not available, are not readily available. They are not available off the shelf like in some other areas of science. In fact, these projects push the technology frontiers themselves. So for example, when CERN went from the SPS to LHC, I think several technology frontiers were pushed. And they involve many a times yet unknown technologies. So these projects require considerable upfront R&D and prototyping efforts. And naturally, then they have inherent uncertainties associated with them. Now, because of these uncertainties in the underlying technologies, these mega science projects often go through cost and time overruns. And these are not the only reasons. Sometimes they happen because of misinformation among the public, sometimes because of change in the regulatory regime. But many a times they also happen because the technologies are not known and they take time in getting developed. And these mega science projects do lead to important technological spin-offs. I mean, one of the most quoted example is the World Wide Web, which came from CERN. We also know that grid computing, CERN led the way. Then this touch screen that we use in all our phones came from CERN. So there are technologies of that kind. People are talking about these GEM detectors, gas electron multiplier detectors, which are expected to revolutionize imaging, medical imaging particularly, so on. Now, in the Indian context, industries have been involved in these projects in a big way, because since they're massive engineering projects, you can't do them without industry. But how has the Indian industry have been involved so far? So far, the R&D and design of components have been largely done in laboratories. I say largely because I know in the case of SK, for example, Persistent Systems has been involved from a much earlier stage. L&T has been involved in a much bigger way in the context of ITER and so on. But largely the R&D and design have been done in laboratories. Prototyping is done both in laboratories and industry, but production of components is done in industry. And the industry is involved now. In fact, as a part of this Mega Science Vision 2035 exercise, we have a long list of industries that we have compiled. And we find that there's a huge number of MSMEs which are involved. There are not too many big industries. The question is, what is our dream as far as industrial participation in these projects is concerned? Okay, the ultimate dream is that a consortium of Indian industry bids for such projects as turnkey projects. But anyway, that's since a big dream, so I have struck it off. I mean, okay, some consortium of industries bidding for a project like Large Hadron Collider. I mean, is very difficult to imagine. I don't think we have examples of that kind. But there can be smaller examples. For example, when this 3.6 meter telescope, which has been installed at Devastal, has been built by a company in Belgium called EMOS. I mean, that's not a very big company. This is about 100 crore project. And it's a company of professionals, so, companies of this kind, there is no reason to imagine that we cannot build a company which can produce accelerators to produce isotopes for medical diagnostics. That's a huge market. Similarly for some of the other things, I mean, cancer therapy accelerators and things like that. Most of these accelerators at the moment are imported. So, okay, that's the ultimate dream, and I have struck it off. But before that, I mean, can the Indian industry move up the value chain and does more of R&D and design also? As I said, in some cases it has already happened. But how do we do it in a more systematic fashion? What do we need to do at the government level? What is it that the industry should do? What will it do? It will bring in high-tech employment and manufacturing in Indian industry through these mega science projects. All our students who are coming out of this, who are getting trained in these projects can find jobs and in the industry, and thereby bring in value for the industry also, because these are largely international projects at the very cutting edge of technology. Then, can the Indian industry compete for open global tenders for components floated by such projects worldwide? You see, these projects, when they're constructed, large chunk of the components which go into building the projects are brought in by what is known as expression of interest route. So every partner says that, okay, we will supply these components, and then they get in touch with their R&D labs and industry and produce and supply them. But there are still items which are tendered, for which open tenders are given globally. So can our industry compete? And what do we need to do to enable our industry to do that? Then can Indian industry pick up the spin-off technologies? Okay, there is a spin-off technology. Then can someone pick it up and then develop it further and take it to the translation and commercialization stage? So these are some of the questions with which we struggle, and this is not to say that things are looking bad. I mean, we are, our engagement with mega science projects started in the mid-1990s with India's CERN collaboration, and we have come a long way since those days. We are today participating at least in half a dozen large international projects, and there are, national projects going on and so forth. So, so the question that I would like to pose before our industry leaders is how to achieve these goals. And obviously, there will be some other things also mentioned by our participants. And we need ideas from industry. I mean, what is it that the government should do? What is it the institutions should do? And what is it that the industry should do? So I'll stop at this point, Dr. Reddy. Thank you.
Thank you, Praveen. That's nice summary and good questions to the industry. And then I request Anand Deshpande to provide more insights into this. Deshpande, you have some presentation to do, or just going to speak?
Yeah, can you hear me now?
Yes, we can hear you.
Okay, so let me start by first thanking you all for inviting me here for this session. I guess Professor Asthana has really posed a new set of questions, because when we were discussing this earlier on, the intention of this session was to help students look at alternatives in terms of finding jobs in case they decide to do other things as well. So I'm going to try to mix the two sessions a little bit, and first focus on the students part first, and talk a little bit about how astronomy students can make successful careers happen in other areas as well, and share a little bit about how Persistent is very keen to work with astronomy students and help them make their careers as well. And I have with me today, I guess, a fellow astronomer in some sense. So I want to introduce Kaustubh Wagmare to you. Kaustubh, can you please turn on your video?
Yes.
Yeah. So maybe Kaustubh is one of like one of you, maybe I'll have him share a little bit about himself first, and then I will kind of get into a few quick discussion items, and then what I hope is that we will have time for questions towards the end. So Kaustubh, maybe first, if you can introduce yourselves very quickly.
Sure. Hi everyone, I'm Kaustubh. I'm currently working at Persistent Systems in the machine learning competency, where I've been working in applying data science techniques to digital security. I've also been researching operationalization aspects of machine learning. But prior to that, I have done my PhD in observational astrophysics from IUCA, and I spent another 4 years there working on data techniques in biology and astroinformatics. So now I'm here at Persistent. I'm looking forward to interacting with you all.
Thanks, Kaustubh. So what we're going to do is to do this in an interactive way. Maybe can you share the presentation I sent? Sure. So let's get the presentation up very quickly. And what I'm going to do is to sort of spread this discussion into 3 or 4 sub-segments. In the first segment, I'm going to try to spend a few minutes. Is the audio still good?
Yes, yes.
Yeah. So, so in the first segment,
I don't have screen sharing rights. Maybe you do.
You can't share it?
can you give Kaustubh screen sharing rights as well?
Yeah.
Okay. So while his screen sharing rights come up, what I'm going to discuss today is in 3 or 4 parts. In the first part, I want to share with you ideas about what students at this stage in their career could be thinking in addition to the astronomy work that you are doing, so that you are better prepared for the job market in the future. Then I want to spend a little bit about how astronomers can, when they start looking for jobs in the market, what kind of things they may be asked and how should they position themselves in that context. And then finally, I want to spend a little bit of time trying to even suggest that, entrepreneurship is a very exciting career for people, and you may want to look at that as an option as well. Okay, I want them to close it. All right, can you move forward? The slides.
Oh, okay. Sorry.
Go. All right, so let me first start by congratulating all of you on your success. And I wanted to reassure you that the science skills that you have acquired, and including some of the soft skills such as tenacity, focus, contextual awareness, and persistence are super valuable for you as you plan your career in the future. And this is sort of what I want to mention a few things here. Go to the next slide. Stop. So very briefly, I wanted to share your previous slide. Minus. Yes, stay. So, I work with a lot of people in the through the career and trying to help people manage their careers. And here's the advice I give people in terms of how they should look at their 40-year career. So some of the people who are graduating from college typically are in their early 20s. And I know for a fact that astronomy PhDs are of course different, but in the first 10 years of their career, I expect people to focus on learning and networking. And in the second 10 years, I would like to see that they are establishing an identity. And in the third 10 years, they should pursue their dreams for a corner office. And finally, they should set themselves up for retirement and future benefits. The next slide. So now, when I'm talking to you all, I'm referring to your first 10 years of your career. And I think the key skills for you to learn are, one is to, how do you become a good learner? And then how do you become a good networker? So those are the 2 main themes that I'm going to spend the next few minutes on that. And I'm going to use Kaustubh to explain to us how he did it and what worked for him. So can you go to the next one as well? So one of the most important things that all of you should consider as you are in your grad student days is to figure out how you learn. And if you know how you learn, then you will be in a much better situation for the rest of your life, because clearly we are in a model where you have to learn on an ongoing basis. So learning never stops. And the earlier you figure out how you learn, the better off you are. Now, by this, what I mean is, especially during the COVID, I found that, you can listen to a lot of podcasts. So some people, and I found that I find learning is far easier when I'm listening to something rather than when I'm speaking about it. And I also find if you teach something, it's a good way to learn. So there are many of these kinds of things that you could be doing. And I'm going to ask Kaustubh a little bit to share how he learns and how does he look at building a personal brand and what did he do in college or while he was a student to make his own brand happen.
Yeah. So I think the most important thing that I ended up doing was to be very public about the kind of work that I was doing. So I was involved in a lot of outreach. I was involved in interacting with groups beyond academia. So I was actually interacting with various meetup groups locally in Pune. I was talking to people, I was presenting my work, and I was trying to bring out the point that all the skills that I was applying for solving my astronomy problems were directly relevant to the problems that they were interested in solving for their industry. So that was one. I always was active on LinkedIn. I had a personal webpage. I blogged quite a bit and shared my technical expertise, including on some very complicated industry problems openly. So those are a few things that I did.
That's very good. Actually, Kaustubh, you are quite unusual. Most people at that age don't necessarily have web pages of their own or whatever. But I have found one specific thing that, in some sense, what happens is that this is one thing that we Indians don't do as well as we should. We tend to sort of think that networking is a wrong thing to do and taking favors is a bad idea. But the reality is that we all depend on each other to succeed. And what I wanted to leave as a big important message for all you students is that you need to leverage the network that you have for getting industry success. And Professor Asthana already shared some of the large industry academia projects that are going on. And this is a great opportunity for all of you to participate in them. We as industry are starting to participate in some of these projects such as the SK and the TMT, etc. And I think there are opportunities to learn new things as part of this. And there's also a lot of activity happening around hackathons these days. And this is again another place where I think you all can learn a lot more in terms of interacting and playing along with certain other people. Go to the next one. And then finally, I just wanted to leave with you a few ideas on computing skills. Now, I know people who are not in the software industry think that we are stealing people from other industries in a big way. But the reality is that if you're looking for jobs and in the long term, I think the circulation between the software industry and non-software industry is going to happen in a big way. And if you were to ask me the hot trends right now that you could be looking at, of course, it'd be data science, machine learning, and ML ops and things like that. And everybody is doing machine learning on everything. Cloud programming is certainly another area that I would invest in. 5G and edge computing was already mentioned by Professor Asthana as well. So that's again an area. I'm a big believer that Web3 and crypto is going to change the way we look at our world. And I would highly recommend looking at this. And then finally, security and privacy. And I also just want to mention that software development methodology and the buzz around how do you do agile development and SRE and any of these kinds of things are also very relevant and important. So trying to be aware of the technologies and all of that can be very useful. Now, let me just shift gears, go to the next slide. What happens is that, while you might do all of these things and you start applying for jobs, at the end of it, the recruiter who is recruiting you is thinking about it in a particular way. So I think one of the important things that you need to think about is that if you are looking for jobs in the industry, then you need to make your skills sort of in a way such that they are much easier for the recruiter to understand. And if I want to leave one message for you all here, the most important message that I would like to say is that, yes, you can apply to LinkedIn, open vacancies and all of that, but those will not necessarily find you the best jobs that you're looking for. I think you all have very special skills that you guys have learned in your astronomy degree and your PhD program. And I think you will be extremely successful if you are able to convince other people about what you can do for us
rather than just showing up and just saying that here is what we have done so far. And I think that is the key to the success of your finding your jobs. And I want to just let Kaustubh comment a little bit on how he found his job at Persistent and how it all happened. Because I think it's a very interesting case study. He tried a few times and had to do something else to make that work.
Yeah, so in fact, for the first year of my job search, I had countless number of rejections and heartbreaks. And I did a lot of analysis as to what was going wrong. And I realized that the biggest mistake was that when you apply jobs on an open platform like LinkedIn, you apply job or Naukri or Monster or whatever, what happens is your resume has to be screened by HR representatives who have a job description, and they are trying to search for matching words between your resume and job description. And when they don't find it, it doesn't even reach the interview stage. And when you do reach the interview stage, somehow you end up speaking so much astronomy that they are not able to understand how are you going to use these skills to solve the problems that we are solving day in and day out. And then later I changed gears. I started attending more meetups. I started speaking with industry leaders, both senior and mid-level leadership. And then I started talking about the work, the skills that I had acquired. And then when I started seeing job opportunities, I actually started interacting directly with the mid-level leadership. I told them that I would be interested and this is what the value that I could bring. And that got me into much better position in terms of interviews. And that's how it happened, right? So first 1 or 2 interviews with Persistent were a bit confusing for both me as well as the interviewer. But as soon as I adopted this strategy, it worked out well. They immediately understood what I could bring, and the rest is history. I'm here at Persistent right now.
Thanks, Kaustubh, for saying that. And I must say that the recommendation that he got from his advisor, which is Ajit Kenbavi, was very valuable. And essentially, Ajit called me up and said, hey, take care of this kid. So that really helped. So if you can do something like that, that is a very good way to get into the job scene rather than just go through the channel from the bottom. Go to the next slide, please. So this is another question that I have heard from some people saying that, I love theory. I'm a theoretician. I do mathematics. I don't feel like doing a programming job. How can I become a programmer? And that's what IT industry is looking for. So I just want to leave this one idea with you that I think if you're looking for one skill that is always going to be in great demand and is the most exciting thing to do, that is to do sales. And if there is one skill that I would like anybody to teach in college right now, that would be sales skills. And then the second most important skill that I would like to tell colleges to teach would be on how to manage your own money, because all you guys are going to get quite well off, and understanding how to manage money is an important skill that I find kids are missing at the moment. But really, getting a skill in selling is kind of very critical. Now, let me just very quickly give you a very short overview of, let's just move to the next one. So at Persistent, we are hiring, and let me see, I'm not, stop for, okay, go back. Just put that Varun button. Yeah. So instead of doing a full-on Persistent pitch, I'm going to just give you a few minutes about what we do at Persistent and let you know that we are hiring at Persistent. So anybody looking for jobs, we are certainly interested in hiring you at Persistent. Persistent is a business I started 32 years back in 1990. We are about 18,000 people now worldwide in 18 countries and in 53 to 54 locations. We tend to work with mostly the business of transforming their business because of software. So we are a 100% software-driven company. And we also work with a lot of scientists across the board. And we've had this rich tradition of working with astronomers. So we've had a 25-year plus relationship, I would say, or actually it's more than that. The first time we started working with astronomers was in 92, 93 around the APES++ project, when there were a bunch of open source software being built as part of NCRA. And over the last 25 to 28 years, we've had extremely good relationships with all the astronomy people. And as Professor Asthana mentioned, right now there are these mega projects coming in where I think collaboration between students and astronomers and industry people together can really make us successful in some of the challenges that Professor Asthana talked about. In some sense, when I sit on the other side of the fence, if I ask most of the programmers from computer science department, go figure out astronomy, it's pretty hard. They don't have a whole lot of incentive to do it at the moment. However, working together in a collaborative mode will allow this to happen. And I think the awareness of the grand scale of these projects is not always available to people. People are by and large looking at short-term gains, and that's part of the reason why this doesn't happen. So I just wanted to stop here and leave you with one last point that I want to make, and that is quite important. For the last 2 to 4 years now that I've moved off my CEO job at Persistent, I am in this business or mission to help people become entrepreneurs. And I believe that all of you in this room are very privileged. You are very capable and you have done many exciting things. And I think if you look forward, I would like to see you be job creators rather than job seekers. And that's the message I want to leave you with. And I'll stop here and we'll take questions in the second round when we get a chance to discuss your specific questions. Thank you very much.
Okay, thank you, Anand, for that excellent insights and then job offerings to many of PhD students here in astronomy. So now we will go back. We go to Laxmesh. Are you there? Okay.
Yeah.
Laxmesh, yeah, please go ahead. You can. We have your presentation here.
So I have shared my screen. I hope it's visible to all.
Oh, okay, fine. We can see your. Please go ahead.
Okay. So good afternoon and thanks a lot for this opportunity to speak to such illustrious people and great panelists, and of course to great thinkers and people who see far beyond. So it's really an opportunity for me to engage with you. So what I thought I would do today is take this session into 2 parts, where I would like to share some of the projects which we at Larsen Toubro have executed, some of those mega science projects, and what are the kind of challenges that we faced while executing those projects, and how you have as students with certain capabilities, if we had people like you, how could have we done these jobs better, faster, and made it more profitable? So I would like to, before I go further, I would like to share some of the salient, the spread of Larsen Toubro. I'm not very sure if many of you are aware of this organization called Larsen Toubro. It's an Indian multinational. It's about $20-25 billion global Indian multinational engaged into multi-domain businesses. I would like to pick some specific aspects of Larsen Toubro which I felt could be relevant to the audience today. And therefore, I would call L&T system of systems. When I use this word system of systems, picked up some of these. For example, if you were to look at a smart city, the smart city is not just one solution. It is a basket of solutions. And to get to each solution, there is an enormous amount of interface, connectedness, multi-smaller systems all bringing together. So smart city is a living entity. Now, take for example, a nuclear power plant. Again, it's a system of systems. I would anyways touch upon the ITER Tokamak reactor a little bit later. Look at something like a complete defense system, which involves all kinds of platforms, communication, beyond sight, distances are engaged, and everything needs to happen absolutely without any latency. For example, a simple under the tunnel systems or the metros or the rail networks, which many of the cities have these days across the world and certainly in India. I mean, we don't really see it from on the surface, but the complexity in managing, again, these are living systems, large ships, building and managing an airport, again, living large systems. So why am I picking up these kinds of systems is because I would like to move forward and say that some of those, I would like to pick 4 large mega science projects and would like to discuss the challenges that we have come across in that. The first one that we are currently executing is a 30-meter telescope. A 30-meter telescope is a project which is engaged. It's a global project. About 7 countries are involved in it. And each country is a partner. And within each country, there are different companies within that country which are partnering through that particular country. And therefore, there is country-to-country interaction and there company-to-company interaction across. Now, while I would not like to dwell too much about what is this project about, I would like to look at how a project which was kind of conceived decades back, when I use the word decades, I'm very clearly mean decades, conceptualized, and because it is very difficult for one country to invest in such mega project, the ability to build partnerships, convince different countries about the need for such an investment, and convincing that this would be an investment with good return, good scientific return, good knowledge return. So going ahead with a project of this nature itself takes decades. After having say, okay, you got in your partners and you initiated, kickstarted, the very important thing is, because the reason why they're called mega science project is because there are technologies which are essential for realizing this, but they don't exist today. Or they exist in such small niche, very tightly controlled global pockets that your access to that is close to impossible. So the first step itself is a giant leap and is a doubtful one. The second and very important aspect when you get into this kind of a project is, many times we do know what we know, but we don't know what we don't know. And that's where we kind of get into big potholes on the road. The third element is most important thing in any commercial project is the time value of money. We might have started with a budget of X billion dollars to be realized and the project to be realized, say, over the next 1 decade. But if the program stretches for another decade, and this X billion dollars would have become 2x, 3x. And that's the magic or the flip effect of the time value of money. Friends, the most scarce resource is not material, is not knowledge, is not talent, is not resources. Believe me, it is time. And if you would like to make the switch between light years to seconds, I think this can be a major mindset change of how to become an astronomer through a scientific driven business person. I would like to pick another project, and this is a project, the only third of its kind in the country. and proud to have been part of this. This is a hypersonic wind tunnel system. And a hypersonic wind tunnel means we are looking at generating velocities in excess of 20-24 Mach. Now, again, the challenges here is, as I said, there are only 2 other countries who have done it, and it's one of the most secretive core technology, and no one would like to part with it, which means the technology needs to be built absolutely in-house. Now, which means here is a situation where you know what you don't know. You know that there are some people who know it, and you also know that they are not going to give it to you, which means you need to really dig out and know your unknowns. Now, that's the biggest challenge in these kinds of mega science projects. For example, in this particular project, the very concept is when you are able to generate velocities of air at 24 Mach, what happens is air liquefies. And if air liquefies, just imagine a drop of bullet traveling at 24 Mach. It can rip through buildings. It can smash out cities. Droplet. Now, therefore, how do I avoid that? Now, to avoid that, the very purpose of generating velocity now becomes a problem statement has become, how do I avoid or how do I eliminate air liquefaction? The entire purpose of the project now shifts towards something to prevent a non-occurrence. So this is how a project gets into technological challenges step by step. Of course, I'm glad to share that we have executed such a technological project fastest in the world. We have done it at a world record time. Complete setup right from scratch to finish and blowdowns testing. In less than 5 years, no country has ever done this. And this is completely with in-house technology. I'll pick another great project, and this is really the mega of mega science projects. And all of you are familiar with the International Thermonuclear, the ITER, the experiment reactor. Now, fundamentally here, this project in itself is an experiment. That means the outcome of this project in itself is a questionable thing. There is a hope. Now, here we are talking about fusion and of generating carbon-free energy. And we are trying to build an experiment of this. And the experimental project itself is over 4 decades. The Tokamak reactor, what you see is actually there on the screen. It looks kind of a small, small mechanism, but this whole thing is 10-story building of sheer solid steel. It is 10-story building, 30-meter high and 30-meter diameter, made or realized of various kinds of high-strength steels. And because if it's of massiveness, this cannot be built at one place and transported in single piece. So therefore, it had to be, incidentally, this entire the Tokamak reactor, what you see on the screen is built by Larsen and Toubro. And the whole thing is taken to France for commissioning there. Now, the problem with such a project, as I said, one is it's an experiment. Like the whole world is putting in billions of 65, 70, 100 billions of dollars behind an experiment with an hope that the experiment would be successful. And once the experiment is successful, later on, it will become a technology. So that means we are just talking about a proof of concept, which would run billions of dollars and over 3.5 years. So what is, if we have to be part of such a program, one very important thing, many a times such programs are beyond the lifetime of individuals. We cannot say that it is possible within the, somebody joins a company and by the time he retires, it is quite possible that the project would have moved certain phase but not have completed, which means an organization, its people, its systems must be able to be carried through generations within the organization. It must have the processes, the instincts, the competencies that should last those many years. And very important thing here, now coming back to the some of the key elements here is, we do not know, the world does not know that would this experiment would be a successful one. So it is a sheer belief and a conviction with which the world, again, this is a project which has got more than about 35, 40 different countries participating. So it is enormous amount of hope and self-belief. More than self-belief, I call it collective belief in the mankind. Because this is a project, global project of that nature. There will be enormous amount of hurdles, despite enormous amount of global cooperation. It is important to have three very important inherent characteristics: persistence, resilience, and tenacity. Any of these projects would really test out these three characters in an individual. Do you have the tenacity to stay on, to hook on to something like crazy, like as if it was the breath in your life? Like if you don't, you're dead. Can you count it more than your own life? Number one. Number two, would you stay with it for years of not seeing a success? Number three, do you have the resilience to get back and move forward every time you have a failure, you are hit to the ground? Are you ready to get up and get back into the line and start continuing with whatever you are doing? Three very important personal characteristics: tenacity, perseverance, resilience. Let me go through another very interesting, it's a very small project, but something which had accuracies which were unheard of. Now, this was an angular motion simulator. As the name says, we need to simulate angular motion. And the idea was to see if we can simulate 1 arc second. Now, it appears simple, but when we try to convert a need into a design and a machine characters, there aren't any such material or bearings or things which can insulate the rest of the system, so that even a small 1 arc second of motion can be detected. It took us 10 years project and we didn't accomplish this. We were very close, but it took us years together to kind of understand how is it that a particular target or particular objective needs to be achieved. Means you know what you want, but you just don't know how to achieve it. And that is another very essential part. So if I were to look at these 4 projects, and if I were to kind of put all of them into some kind of baskets of competencies, first and foremost, we may be business, but very important thing is scientific temperament, which I think is abundant in all of you. Second and very important thing about in business is not just about money, but enormous amount of mathematics. Mathematical solutioning play a very vital role. But it's all about data generation, forecasting, predicting, enormous amount of mathematical. And of course, we did talk about technical capabilities, and technical capabilities is something where ask those 3 basic questions. All of us know what I know, but many of us do not know what we don't know. And that's where we get, in competitive exams, that's where we get those negative marks. You should really know if you don't know and just leave that ball. But don't try to, play the ball and give a snake catch in the slips. Do you know what you don't know? And if you know what you don't know, the next important question you need to ask is, do I know somebody who knows that? And that's where Mr. Deshpande mentioned about networking. If I know what I don't know, but I know somebody who knows what I don't know, come which may, go and get to him, reach out to him. And if you don't know that, do you know how to find somebody who knows what you don't know? That means we'll have to find mechanisms of going behind. So these are all some of those competencies which I call technical. Then I did mention about the soft skills. Soft skill is ability to just stay forward. Those tenacity, perseverance, resilience, risk management. The most important thing in any of these kinds of mega projects is every thought, every behavior, every action is a potential risk for the very success of the project, commercial success, technical success, timeline success, all kinds of things. So risk management, contract management becomes very essential. Problem solving, we discussed plenty of that. And last, but the most important is entrepreneurship and a business acumen. Now, why is this essential? Because if we are talking about getting into industry, industry survives, thrives on this very aspect. No matter who you are, you may be an engineer, you may be a software designer, you could be a person on the shop floor, you could be a marketing guy, you could be any kind of person, but one common thing that must be there in every individual in an enterprise is entrepreneurship and business acumen. And I would like to sum up by saying, we are all familiar with light years. Are you familiar with quarterly results? I beg your pardon, I have written the quarters, and quarters was just to catch your attention. But what I meant there was light years to quarterly results. If you are able to kind of compress and have those kinds of break the entire project into smaller time fixed milestones, that's the way to manage these kinds of programs. And these are some of those basic competencies which I would love to, you to pick up and inculcate, so that I would say that's when you would become industry ready. Thank you very much. I'll take questions later during the question and answer session.
Thank you, Laxmesh. It's unmuted. Thank you, Laxmesh, those powerful words and demonstrated through those complex 4 projects you have taken up. And then we will go to next panelists, and then after that we can have a discussion. And then I request Professor Sinha to either make presentation or say things.
Thank you very much for having me here, and let me share my screen right away. Is my screen visible?
Yes.
Okay. So I would mostly be talking about this issue of industry and academia working together from both ends, because I have been an academic most of my working life, and of late I have started a company at IISc. So that is about 6 years old story. So let me talk from both the perspective. What I wish to cover in the next 20 minutes is basically I would like to talk about or discuss what is my understanding of the difficulties, why we often fail to take advantage of the enormous talent that is available in the academic institutions, and the industries many times complain that we are not able to get much out of them. Then I would briefly, if time permits, I will go into as much detail as possible to do the lab to market experiment. That's the company I co-founded. And then I'll talk about current partners. But most of the time I intend to spend on the first line, that is, what are the roadblocks and what are the problems? Actually, it's not for want of desire. I am quoting it from the statue of Jamshedji Tata, the founder of IISc. It's there, right there. The portion that I have shown over here is part of the what is inscribed under his statue. And right from the very beginning, the vision of the founder was to have an institution which would conduct original investigation in particular branches of knowledge which are likely to promote the material and industrial welfare of India. So right from day one, that was the vision. And Institute has done its bit trying to provide or open its door to the industry. It has several windows through which it interacts with governmental PSUs like DRDO or ISRO, DBT, and also with other industries through CSIC and SID and so many things. But in spite of that, the problems remain, and I will come to now what I think is the gap as I have understood. What industry requires is basically a product or a solution. They have pain points and they want that to be addressed. However, academic institutions don't develop products. They don't, I would say they are not capable of developing products in the industrial sense, but they are a source of core technologies, which are basically, which they come out of research, which faculty guides and students work on. And these technologies are also transmitted to the rest of the world through publications, and the students get trained and they go around and then they become, the actually main medium of knowledge dissemination coming out of academic institution. Now, while these core technologies may be essential to develop new products and new solutions, they require a targeted translational R&D, which is not insignificant. In fact, that is sometimes that takes more effort and definitely more resources than it took to develop or come out with the core technology or proof of concept. So this investment, the problem is that who is going to make that investment, because it is quite risky. You don't know what you are trying to develop or the so-called product that you are trying to work out, whom it is targeted towards, who is going to use it, and will it be a success when you finally do it? All these are question marks. So this is the one part of the story, which I call the technological gap. But what I have understood, the issue is little more serious. And that is because of the mindset itself of people in the industry and academia are quite opposing in certain issues. Let me start with the first one. What motivates an industry? Of course, an industry has to earn more than what it spends. Otherwise, it cannot even survive, let alone grow. But for academic institutions, particularly in India, money is not what motivates everybody. It's the peer respect that they get and which comes out of publications or research guidance and all that. So that's a problem over here. So if you go and flaunt your dollars to an academic institution that here, take these dollars and give me that, it doesn't really work. Second one are the time schedules. The industry has to work within certain time schedules. We just heard that we need to convert that light years into quarters. I think Sir was trying to be a little polite in saying that academics don't respect for the time schedules, and which is true, because in academic research, researchers don't like to be told to rush. They take their own time. They have to go through a particular process. Many times the work done by students only, and the students also need to be trained. So first 1 year or more goes into preparing the students to take up that work. So this is a issue. Third issue is area of interest itself. Industry is working in a particular area or a particular, at least that particular vertical. The person or the group which interacts with academic institution, they go with a particular goal and particular objective. Academics don't look at a very small part of the problem. For them, it is a bigger picture that interests them. They would like to do something which is more generic in nature rather than addressing only a very, I would say, pinpointed issue. Then feasibility concerns. If an industry takes up a project, the success of that project is all important, because you can't spend $2 million and then at the end say, sorry, this doesn't work. But that's not the case with academics. Academics, I mean, I am very fond of saying this, there is nothing like a failure in a research. You were hoping to get some result, but at the end of 2 years, you find that no, this doesn't work. If I follow this route, I don't get X, I get Y. But that itself is a result in a way. You can still publish it and you can still get some credit for it, even though this is not what you expected. So there is nothing like a failure there. Whereas if you are trying to develop some product and you come out with some another product, that cannot be acceptable. It is a failure when it comes to industry, and a lot of money has been spent. So it can lead to disastrous consequences. Then interest in an area, we have just heard that it has to be long term. You have to be patient. You have to go take the project through its thing. Whereas academic, my time would be 3 years, because that's the typical time allotted to a research student. And once the research student leaves, another one comes. I can't give the same problem to the new set of students. They have to be given something different. Then team effort. There always have to be a team where academics really work in their silos. In fact, I can give you examples of labs which are named after the professors. So team effort it's not a very common thing in academic institutions, where it is a must in the industry, because every product or solution is by necessity multidisciplinary. And confidentiality, of course, there must be a confidentiality, and academic institutions have to publish. All these are real issues, but I have highlighted 2 of them, which are the real deal breakers. One is the time schedule, and another is the feasibility concern. My experience is that these are the 2 issues which really kill the interaction between academia and industry. Okay. Now, I would like you to take a look at it in a slightly different way, or rather opposing way. Can I use this mindset if I agree and if I understand that, yes, this is the mindset of the 2, rather than giving up that, okay, this is too much of difference, it cannot work together. Can I take advantage of it? For example, look at the motivation. Now, when academics are motivated by their expert, can we give them the credit for the work that has been done? Now, as an industry, if you want both the credit as well as the profit, then you better do it on your own. Otherwise, if you are getting it to be done by an academic person, give them the credit for the work that they have done. For timelines, we need something in between. This is, as I said, is a real deal breaker. So if you just try to do it with academic institution, it doesn't work. Same with feasibility. So quickly, I will move on to what I am trying to do. And I would say that I have been reasonably successful in my first attempt. I persuaded IISc to help me start a company there, precisely to bridge these gaps, because I believed I understood the problem. And this is the strategy with which I approached IISc, that first we will keep ourselves aware of what is going on in the academic institutions. And I have also taught research laboratories. Here I mean the CSIR labs, because they also have wonderful technology, some of them. So first of all, it is very important for my organization, Lab to Market, L2M, to be aware of what is happening in academic institutions. So our people attend conferences, they attend lectures, they go through every professor's websites to know what is going on, what they have come out with. And then we always keep discussing, okay, this core technology has come out. Which industry may want to use it? Or where we can utilize it to develop a new product or a new technology, new solution? And then question comes, who would fund it? So approach the organization who has a pain point where this technology can be utilized effectively to address those particular pain points. Ask them to fund it. And then you have to set up a team and adequate infrastructure to develop all these projects. So this is what is needed to meet this concern of time schedules and feasibility concern, because that group sits in between and makes sure that the product is developed to meet the requirements as laid out by the industry, and it is delivered within the time frame as required by the industry. So this is very important that we set up a right team. And Lab to Market, we decided right from day one that it will not go into manufacturing or all that. It will remain a technology company, and our revenue model will be by licensing the technology or products that we develop. So this is the strategy with which we approached IISc, and IISc agreed to support us. We are seed funded by IISc. They hold equity, plus we also give them 1% royalty on the revenue that we get from IISc. From whatever revenue we earn, 1% has to go to them. We got funding of nearly 1 crore from them, and so this is not really a bad deal. We have access to all their labs. The Lab to Market is treated as a department of IISc when it comes to utilizing the services of its faculty member or other laboratories. We get access to the patents and other IPs of IISc, and we always engage IISc faculty for taking up R&D projects. And then IPs are shared. Then whenever we generate an IP or file a patent, it is jointly with IISc. Some of you may know about IISc. It's a beautiful campus, and we have 500 plus faculty for about 5,000 students. More than half of those students are actually pursuing PhD. So it's primarily a research institution. This is the founding team. I have already been introduced to you. My co-founder is an ex-railway services engineer, signaling engineer, and he's also a serial entrepreneur. So while I knew the problem, I also knew my limitations as an academic. I knew that if I try to do everything in a business, I am not likely to succeed, because I don't really know how to raise funds, how to manage employees, and so on. This gentleman had the domain expertise of the railways, plus he had quite a few startups. So he was an ideal partner for me, and he knew me because his company had hired me as a consultant when I was in service. So we got together, and we also persuaded IISc for the first time. I think it's the only time. We told them that we need the services of some core faculty, but we won't have money to pay them consultancy fee. So can we use their services by giving them the only thing we have is our equity? So once again, IISc agreed, and these four, Professor KJ Vinay, he is currently the chairman of Electrical Communication Engineering Department. Professor Umanand, who is currently the chairman of Department of Electronic Systems Engineering. Professor TV Prabhakar, who is in networking, and Mr. Harish Dagle on embedded system. These are the four faculty members who are serving in IISc, but they hold equity in our company and support us in that process. So we have a lot of industry partners as also on today. We have MOUs with them, NAL, RRCAT, Indore, that Raja Ramana Center for Advanced Technology. Actually, this is a DAE cost center, but they work with us. We have taken C-Dot technologies to the railway domain, and we are working with SERC, that Structural Engineering Research Center at Chennai, because we just got a project from K-Rail for developing a structural health monitoring system for their Silver Line project. So we are working with them. And we have several academic partners apart from IISc. We are signed up with VNIT Nagpur. Then there are 2 colleges in Bangalore, then college in Chennai, because we need to work with that. And we are in the process of signing MOU with the Anand Sagar University. So our current focus is on railways, because we have one co-founder is railways. He provides the domain expertise, plus he knows what are the pain points which really need to be addressed. And actually 2 days ago, we were in news for having signed up with DFCC, that Dedicated Freight Corridor Corporation of India Limited. We have signed an MOU to develop machine vision inspection system for their wagons. Just 2 days ago, that was done. So we are trying to make the railways operations safer and more efficient. So these are the different challenges. I don't have time to get into detail of that. We have already implemented 3 projects about 1 year. One is known as WILD, that is basically to we instrument a section of the rail, and all wheels passing over the instrumented zone get automatically inspected for their quality. There is cyber signaling, which we believe is the future of signaling, railway signaling. This has been implemented in JSW in Karnataka near Ballari. Then we have an onboard monitoring system we have implemented in 2 rakes of Rajdhani, which are running. So then I think I would skip all that because I run out of time already. These are views of some of the projects that we have done. This is some work that is going on in this. I think my time is up. So I would stop here, and maybe later on, if there are some interest there, I would be very happy to address the questions. Thank you very much.
Thank you, Professor Sinha. That was excellent talk, and then demonstrated now how to go from academic to the industry. And you were one of the finest examples in that. I think we need to take from there. And then now it's open to discussion, and people wanted to ask questions or any suggestions related to how to bridge academics and the industry. Okay, Mudit.
Hi, Harsh here. So I have this doubt regarding like the bridge, the gap that is there between academia and your industry. That you said that like for example, persistent and L&T requires a lot of technical skills, but it is not a necessarily thing that all the researchers are over here actually have those. So in for specific examples, like you want to develop software, but people over here have the programming skill, but not to exactly develop the software. So how open are the industries to bridge that gap? Like how much time do they give to the researchers to actually settle down into a system, and how do you like make sure that they actually settle down in a system?
Okay, let me take that question. Like that, if a person is trying, there is nothing like settling time. At the same time, we don't allow people to settle down. We want people to be kind of restless and put always that time as the most scarce resource. Because when you have that, I'm sure results would come within time. But you are absolutely right. I can't expect an overnight change. So usually we give about a year's time.
Anand, you want to say something on that?
No, I think, see, I would say that by and large, we in the industry are very open to having people who have slightly different skills than what we have, because we work in teams And as a team, as long as we are able to figure out what we need to do, that's usually works out well. Let me be more specific. See, what I find is that astronomers actually have very good data and analytics skills, and they have pretty decent programming skills. Problem that happens is that if they start competing with fresh computer science graduates, then if we try to box them into a certain box, then it will not work out very well. So I think it is important for you to not try to hit into that same box as fresh computer science BTechs or somebody like that, but position your skills as saying you understand not just the programming alone, but you also understand the context, the domain, the maturity that you bring in. The fact that you have done a PhD has demonstrated certain different kinds of skills. So you have to position yourselves in a box where you are the box and you're not into somebody else's box. And the easy thing for industries to do is say, hey, I need this, you meet my requirements, and I talk to you. So I think it's a little bit of give and take that you need to do. But if you take that step to position yourselves right, I don't think this is a huge problem at the moment.
Thank you. Follow-up question on the same front is that, again, like Professor Sinha said, that like essentially you are looking for long-term investment. When you are hiring an employee, you are essentially making an investment to that employer, like looking for the long-term, how much he or she can provide you to your company. So again, in the starting, like he may need to develop some skills, may need to get along with the environment. So does companies offer something to the employees, like giving some certain programs or allowing them to just learn new skills with some time at the initial stage? Or do you just want like a kind of a ready product that you want to use your company for the long term?
So let me answer that by saying that, yes, we do have a lot of training available. All the fresh graduates that come in, they go through a extensive training within the company. And also we have continuous training or opportunities to learn on an ongoing basis for all employees. That said, the point I'm trying to make to you all is that those of you who have spent a career in astronomy and have gotten an advanced degree, have some level of seniority and experience, don't try to hit the same fresher jobs that are available in the company. Position yourself slightly differently, and you can come in the middle of the organization within a short period of time if you are able to sort of market yourselves in the right box. Because if you start to compete for fresher jobs, then you say, okay, I need training, I don't have this and that. The amount of training these days that you need is not that much, and you can easily acquire that on your own. But don't try to come in and compete with the fresh BEs that we are hiring in large numbers. You have a very definite advantage and skills that you should leverage to take advantage to position yourselves right, rather than just accept what the job recruiters are looking for. That is the main point I want to make for all of you, because otherwise jobs, yeah, there are lots of jobs available, and yes, we will go through the training, but then you are going to get paid like the other fresh graduates. So that's not a good idea. You can do a lot better.
Very well said. I'd just like to add on to that, and especially now I'm talking from a very Larsen and Toubro perspective. We look at human as asset and not a resource, which means that an asset needs to be invested in. And the most important investment that we keep on doing, and in Larsen and Toubro, in fact, a lot of people, L&T is L&T, learning and training. So it is a continuous exercise all the time, no matter what position you are. You may be head of the business, you may be at a director level, but there will be always learning. But the very important thing here is, it's not about how much you learn, how much you get trained. It is how much of that you transform into your skill and deploy and apply it into action. Once if you're doing that, then the more and more, that's how an asset becomes a valuable asset. Thank you.
Thank you. There's one question from Mudit. Please go ahead.
Yeah, my question is for Dr. Asthana.
Okay.
About the government policies regarding R&D in institutions and their relationship with industries. You see, some of the recent policies of Government of India says that it's very appreciable that they say make in India and you have to involve Indian industries. But at the same time, there are aspects which are not available in Indian industries. And these policies fails to put a pressure on the Indian industry to generate those resources. On the other side, those policies restrict us in the institution to build something. So it's kind of counterproductive. Related, queries regarding the L1 process when you try to build something, you want to procure a component. It is much easier if you are working in the industries to buy the component which you actually need. But when you are working in the government setup and you are limited by the L1 tag, so how do you overcome such kind of difficulties while you wish to, develop something in government R&D sector?
Well, I think the person has asked a very wide-ranging question, and I don't know if I know all the answers. Okay, first of all, let me let me break it into three parts. First part is that government's encouragement for doing to scientists in institutions for doing applied R&D or industry-oriented R&D. I think that's the first part. And I would only say, and because there's no point in repeating, it's all there on the websites of all these, government departments and funding agencies. I think in the last, maybe 5, 7, 8 years, 10 years, there is there are a large number of schemes and schemes where you can get R&D funding for doing industrially relevant R&D. Okay, that's one thing. There are also specialized fellowships for doing industrially relevant PhD work. So all that is there. You can look at those websites, and so that I think there has been a sea change compared to the time when I joined DST, at the start of my career in 1989. So that's first part. So for opportunities for scientists in institutions to do industrially relevant R&D, there are lot of opportunities now, lot more opportunities now than what used to be available. The second is, opportunities for our institutions to engage with industry. Okay. Now here also it has been on the upswing. Well, first of all, now I think our institutions have mechanisms to encourage their scientists to do industrially relevant research. In fact, there are even schemes in many institutional systems to share the royalties and in consultancy money that you earn and all. There are policies which have been laid down, so that is there. Then this large number of incubators and such centers which have been set up in the past maybe decade or so. So I think institutions are being encouraged in many ways. They are being the emphasis, a lot of emphasis is being laid on our institutions to do more and more industrially relevant research. The third part is a little, in fact, I must admit, I am not a finance expert, but let me just throw some light based on my experience. This L1 problem, see, these general financial rules of Government of India which apply. What is this L1 problem? You should get the best buy for your price. So I think, these things go through this technical evaluation, and then, once something is evaluated technically to be equal, then you go for the L1. Now, so I think most of these procurements, etc., go through these 2 bid processes. And okay. And if there is a proprietary item, there are also well-laid procedures to go in for proprietary items. The only thing is that with increased, levels of transparency and the greater demands on public accountability and people getting very sensitive about it, These things, people have become extra careful. These things do take time. But the general principles seem to be, essentially transparency and the best buy for the price and things like that. But as I said, I am not a finance expert, and I wish someone with that kind of experience was here. So I think, on the whole, the opportunities for both scientists in institutions and institutions are a lot more today to engage with industry and do industrially relevant research. I think that's all I can say, because I think the question was very, broad. So, thank you.
Thank you, Ravi. Please.
My question is to Professor Anand Deshpande. Professor Anand Deshpande, you mentioned that you are you are also interested in letting young people start up their own companies. So how do you plan to do that, and how what is required from a person who has how do we approach you in that regard?
This is a very nice question. I'll be happy to do a workshop for all of you on how to take a PhD idea all the way to doing a business. I did a workshop like this for IISc about 6 months back. And this video is available online in terms of what you can look it up. So if you look for IISc, Deshpande, and how to take a business idea, you should be able to find it. So I am really very passionate about the fact that if you look at India right now, we need almost 1.5 crore, meaning almost 15 million jobs every year. And there is no way, no government, no large company can provide that level of jobs. Real jobs are going to happen when people become job creators. And what I have found, and being a PhD myself and an entrepreneur, I think PhDs is the best entrepreneurship training that you can expect. You understand how to deal with failure, you understand how to experiment, you understand how to try, and you never give up. And those are the traits that no other degree will show you other than a PhD. I think the biggest problem that PhDs have is they have this mindset that if I'm PhD, how can I be an entrepreneur? And that is one thing that if you just sort of shed that piece off, I think the PhDs are the best suited people for becoming entrepreneurs. And today is not the right time, because I think if I'm going to leave this as an open thing for you, if you choose to invite me for another session and give me 2 hours at least, then I'm happy to talk to all of you again and do this very detailed information on how to take it, not just tell you some general advice, but what are the methods that people use? How do you do lean manufacturing? How do you do lean startups? And the whole methodology and how do you build teams? How do you take an idea to experiments to business and all that stuff? So happy to spend time on this. This is certainly my passion at the moment.
Thank you, Anand. So we will look at those opportunities. We are going to have some young astronomers meet. Maybe that time we can invite you.
Yes. And I think astronomy itself, you guys have the ability to discover problems out of nothing in some sense. So, most of us don't realize that there is a problem when we look at the skies, but you guys have the ability to find things when we can see nothing at all. So, you have that great capability. So I'm very excited and very happy to spend 2 hours with you and trying to explain to you how to start a business and how to run a business.
Thank you, Anand. So there may be some questions of the online people, participants.
Yeah, it's hand raised. You can go one by one. First. They can unmute.
You can, okay.
Anand first.
Anand, go ahead. Ananda. You unmute yourself and then please go ahead. Speak up. Okay.
Can you hear me?
Yes, we can hear you.
My question or suggestion is to both persistence and LNT. The problem and solution, both I'm speaking. Problem at the moment is not many people know that these companies are interested in people with astronomy skill. So when you are giving this talk, it is actually a information for many young astronomers who try their luck in trying in your companies. So the other thing is the Indian astronomy, it doesn't really have a quality outreach product so far. For example, the moment you type a black hole, you don't get an Indian picture. You get only picture created by NASA. You want a pulsar to be blipping or a supernova to be exploding. We don't have an Indian animation yet. So if the companies who are interested in astronomy domain knowledge, if they take part little bit in astronomy outreach with this kind of quality animation, then it will spread a lot and this will help a lot. Currently, our astronomy research institute don't produce that kind of quality images. We don't have a simulator or animator or astronomical graphics designer. So if you please help in this way, it will not only spread the astronomy, it will also spread your name there so that people can get connected with your interest. Thank you very much. Have Anand hota.
Okay.
That's a good suggestion.
Indulekha, please go ahead, unmute and ask question.
Yeah. Am I audible?
Yes.
Yeah, I'm from a university and I teach physics, and I was thinking some of these skills which were mentioned, like programming, for example, mathematical skills, analytical skills, are picked up by MSc physics students to some extent. And if they pick up some more, extra programming skills, for example, they sort of fit the bill to some of these skills which were being talked about. So there was some Professor Asthana had mentioned industry relevant R&D projects are mentioned, and these were at the research level. But if you're thinking of MSc physics students, would there be any website or something available where they can become aware of projects which connect them to industry, industry type projects, so that they get an understanding of what is needed in an industry job. And if they have the skills, they can go ahead, pick up additional training or additional diplomas in programming, for example, and try for it. Because they have analytical skills, they have mathematical skills, they have some programming skills, they have imagination, which is a characteristic of a science education as opposed to an engineering education. Thank you.
I guess the question is meant for me. Well, I don't readily recall a program of the kind that you were talking about, but there is nothing that prevents designing and launching such a program. Okay. Under this Mega Science Vision 2035 document in astronomy, astrophysics, there's a full chapter on building the ecosystem. And our team is thinking about such things and, essentially how to enrich the training of our astronomy physics students so that they become more, more industrially relevant and things like that. So I think it's a very valuable suggestion. I'm sure, Professor Anupama is there and many of the other people are there. So, this, if it comes in as a part of the suggestion, then, it can be taken forward. But I don't readily know. If there are some programs somewhere that I am not aware of, that's all I can say.
Thank you very much.
And there is one more, Joe Jacob, please go ahead.
Thank you. Probably this may be a naive question, but maybe relevant to this particular conference. That's why I'm asking. So there are different streams in astronomy, like observation, theory, simulation, or instrumentation. So do you think that the skills acquired in different streams, some stream may be having advantage for getting into industry?
I think I'll respond to that. I feel this instrumentation could be something which probably has a wider and the spectrum of across industries and across profile. Another essential part about the instrumentation is probably it is one step closer to system engineering or system thinking. So I believe that has a wider
Are there any questions from online participants or offline? Dipankar, please go ahead. Sure.
So I just wanted, it's more of a comment and thanking, we are coming closer to the session end. So I just thought, I will highlight a few elements. In fact, Dr. Anand Kaustuv is there. In fact, Kaustuv was in IUCA when he was involved with the digitization, archive, which is there in Kodaikanal. And we built it together. Basically, Kaustuv made the front end of the software and all that. So what I just wanted to mention is, I think this is persistent is more closer to most of the astronomy students and the people who are engaged in data analysis and so on. So we can connect you straight away. So my invitation will be, I think Eswar has told, the new EC team, I will get in touch with you very soon for helping us to revive the Young Astronomy meet as well. And we can have such sessions, longer sessions where more hands-on demonstrations can be there. Even the students can demonstrate what kind of skill sets they have to you and people like Kaustuv and others. Similarly, of course, the L&T, as you mentioned, the instrumentation people, our students who are involved in instrumentation. So my just comment is that from ASI, we are looking forward to have such sessions, but more in person. If you are in person here, the interaction goes beyond, these 1.5 hours. So that is very important. And I will request, you all to keep this in your calendar, and we will definitely want more partnership. The point is, I think what Asana ji was also mentioning is, before you could get into this big, execution, we first need to understand each other and how we can, move forward. For that, we need to meet more often, and we need to build things with a partnership more. So this industry partnership, at least first in principle agreement, then of course, the financial part also is very much important. And then we can approach also, of course, our funding agency, government funding agencies. Asana is there to help us in those regards as well. So thank you again. I just thought, I will just put this remark before we end the session. Thank you.
Thank you, Dipankar. Thank you very much. So maybe just before adjourning the house, maybe one simple thing we can do is to bridge this gap between this, at least these two industries, persistent and L&T, who are here. And then is there a way even to send some people from either PhD or postdoc or doing instrumentation or some kind of analysis, we can send them there some 6 months or 3 months or something, even sabbatical. Now sabbaticals are only possible from one research institute to another research institute. Whether they can go to even persistent systems and L&T, do something which is much more relevant to astronomical instrumentation and then developing new technologies. In that way, they learn both aspects of it, and then they bring back the industry experiences, and then you also learn something from academic perspectives. So I think that's easily doable. So there are a number of directors are here, and then industry leaders. We can put a panelist on our websites and things like that. These are the industries you can really approach them and go there for 6 months.
Yes,
or 1 year.
we'd be very happy to support that. We have had academics come and do sabbaticals with us. So very much supportive of all these activities.
Yeah, certainly. A big welcome. In fact, we really encourage these kinds of, in fact, not just for students. Today, we have these kind of include for faculty as well.
Yeah,
Also one is students, certainly we have those internship and specific projects and exposures and things. But I have also felt that a must engagement faculty to industry is also very essential. And this was also taken up by the IITs as one of a key initiative in the future.
Actually, I would go one step further and say that, you should also take industry people on sabbaticals to
Absolutely
these kinds of places. We've had some of our employees who get very fascinated by astronomy and others and have spent significant amount of time. And I know most of you know these people anyway, but they have been working for astronomy projects while on sabbatical from Persistent. So you guys have some very interesting work that you all do. So, you should market it a little bit better.
It's a two-way system, yeah, both ways. Thank you very much, Anand. That was wonderful. Asthana, please go.
Yeah, I mean, to be very quick, but let me make 3 points. First, I must apologize to all my other fellow panelists, because I think I charted out a very tangential agenda. But anyway, I'm not going to give up on that agenda. We will very soon organize a meeting, because those are the questions that people like us have to face. If you are asking for 10,000 crores, 15,000 crores, I mean, you are put, you have to face those hard questions. And frankly speaking, we need inputs from our industry leaders, in how to realistically answer some of those questions. So we will come back to it. I think for the first time, we have attempted a very comprehensive listing of all the industries who have helped us in these projects, and we will come back to that. So that's number one, and my apologies for going off in a tangent. So that's one thing. The second thing is that I would, this is, well, I'm not neither a teacher nor an industry person, so I have no right to, lecture, but my only qualification now, I'm a senior citizen. So you can lecture, so what, so the point is that, there is some mental block in India. I think the fact that knowledge can generate money is not considered to be a virtue in our social system. Okay, I am very happy to see that this barrier is getting broken. But I think this mental block remains there. Please shake that off first, you see, and before you can become an entrepreneur or you can do anything. I mean, there is nothing, it's as virtuous as anything else. So that's the second point I wanted to make. The third point is that I think Professor Sinha very nicely, and a very inspirational, a very inspiring quote from Jamshedji Tata. It was very nice. But I would also like all our young people, especially, to kindly revisit the Scientific Policy Resolution of 1958, okay, of Government of India, 4th March 1958, that early. And, you just read that document. It starts with technology and how technology is going to replace the demands on capital and everything. In fact, you'll see the seeds of all knowledge economy and everything. I know it's not fashionable anymore to talk about 58 today, but it is all there, and it is, it is credited to have been drafted by Bhabha, and and then also looked at by Pandit Nehru and so on. So kindly do visit that. It is available on the DST website. It's a beautiful document to read, and so that's the third thing I thought I'll mention. And thank you very much once again for inviting me.
Thank you, everyone. Thank you for the panelists to take out the busy schedule and providing insights into this, and hopefully we proceed on these things. And then this is a seed actually we showed now, so we progress on that. Thank you very much.
Thank you very much. Thanks to Professor Eswar Reddy. Thank you. Bye.
Thank you, Anand.
Thank you. Thank you.
Yeah. I'm done. This is your job.